You know, everyone on the internet is talking about Tesla making their own chips. But honestly, most people are missing the bigger picture. They see the tweets and they just dismiss it as another hype cycle. But what if it's not? What if hiding in plain sight is one of the most aggressive moves any company has ever made in the AI hardware race? Welcome back to AI Verdict, where we do the research so you don't have to. In this breakdown, we're going to trace exactly what Tesla's Terafab project is, why they're spending up to $25 billion on it, and what it means for the entire AI chip industry.
So, it all kicked off again with this classic, super cryptic post from Elon Musk. Terafab project launches in 7 days. And yeah, it looks simple, right? But this little tweet, it's just the tip of a massive, industry-shaking iceberg.
And I totally get it. Your first reaction is probably, oh great, here we go again. Is this just another hype cycle? And you know what? That's a totally fair question. So let's actually break it down and see if this is the real deal or if it's all just smoke and mirrors.
So what is Terafab? Well, in the simplest terms, I want you to think of it like a Gigafactory. But instead of making batteries, this thing is designed to build some of the most advanced 2-nanometer AI chips on the entire planet. It's a Gigafactory for silicon.
And let's be really clear here. This isn't some small R&D project tucked away in a corner. The investment for just the first phase is a staggering $20 to $25 billion. That number, all on its own, should tell you everything you need to know about how serious Tesla is about this.
So what does that kind of massive investment actually buy you? Well, it buys you scale. Unbelievable scale. The target here is to eventually reach 1 million wafer starts per month. And look, if that number doesn't immediately sound absolutely insane to you, let me put it into perspective.
Okay, here's that perspective. At full capacity, that 1 million wafer starts per month would be roughly 70% of TSMC's entire global output. We're not just talking about being ambitious here. This is an attempt to completely rewrite the rules of the whole semiconductor industry.
Which, of course, brings us to the biggest question of all. Why? Why on earth would a car company take on a monumental, incredibly difficult task like this instead of just, buying chips from the experts?
Well, the answer really comes down to 3 key things. First, their internal demand is just astronomical. We're talking about chips for millions of full self-driving cars, the upcoming Cybercab, millions of Optimus robots. Musk himself has said that existing suppliers just cannot produce enough. Second, it's about eliminating geopolitical risk by building right here in the US. And third, it's the exact same vertical integration playbook they mastered with batteries. Build the machine that builds the machine.
And Musk highlighted a really crucial detail here that most people just completely miss. The bottleneck, it isn't just about the main processing chips. He pointed out that there are currently 0 advanced memory fabs in the United States, which makes the entire AI supply chain incredibly fragile.
But here's the thing. Tesla isn't just building a factory to build any old chips. No, they're building it to mass produce their own secret weapon, custom silicon. And their next-gen chip, AI5, is where this whole plan really goes from ambitious to absolutely revolutionary.
Just look at this comparison. Analysts estimate the AI5 chip will basically match the performance of Nvidia's flagship H100 GPU. But then look at the power draw, 150 watts versus 700. That's a 4.7 times advantage in efficiency. This isn't just a small improvement. This could fundamentally change the economics of running massive AI data centers by completely slashing power and cooling costs.
Okay, so how do they actually get there? I mean, they can't just flip a switch and have Terafab running tomorrow. The plan is what you'd call a bridge strategy. They'll keep designing their own chips like AI5 and AI6 and use partners like Samsung and TSMC for the initial production runs. But the long-term destination, the home for all future chips from AI7 and beyond, is going to be Terafab.
All right, let's zoom out for a second. Because if this actually works, if they really pull this off, the ripple effects are going to go far, far beyond just Tesla. We could literally be looking at a new world order for the entire tech industry.
So first off, if Tesla can churn out these hyper-efficient chips at that kind of scale, it could dramatically lower AI computing costs for everyone. Second, it just throws a huge wrench into the traditional fabless model, where you design a chip here and build it over there. It would also be a massive boost for US tech sovereignty. And finally, it gives Tesla a structural advantage that competitors just could not replicate without spending years and billions of their own.
But
All of that comes with a big if. And with such massive potential rewards, you'd expect equally massive risks. So let's be very, very clear about this. This is not a sure thing, not even close. We have to talk about the immense, almost unthinkable risk involved in this $25 billion gamble.
And this slide really gets to the heart of the whole story. On one hand, you have the unprecedented risk. I mean, giants like Intel and TSMC took decades to master this incredibly complex process. But on the other hand, you have Tesla's track record of doing what everyone, and I mean everyone, calls impossible, from landing rockets on boats to building gigafactories from scratch in record time.
This quote from a prominent Tesla observer just sums it up perfectly. He said, and I quote, "It would be reasonable to expect them to fail at chip fabrication." But he quickly followed it up by saying that he wouldn't bet against Elon. That's the tightrope this entire project is walking on.
So when you boil it all down, when you strip everything else away, this is the real bet. It's a bet on controlling the entire AI stack, from the software that runs the models all the way down to the custom silicon it runs on. Total control. So with Terafab officially launching, this is either going to be the smartest move in the history of tech or the most expensive lesson ever learned. Which leaves us all with the ultimate question. Can Tesla actually pull this off? Can they build a 2-nanometer fab from scratch? If you found this breakdown useful, hit that like button, subscribe, and drop a comment telling us what you think. We'll see you in the next one on iVerdict.